Hi, my name is John. I will be going over Pearson, Common Core, Algebra 2, Chapter 4, Section 3. I believe it starts on page 209. There it is right there. And the name of the section is Modeling with Quadratic Function. Okay, so I'm going to be doing a little problem for you. Start off with an example. And what is the standard form of the quadratic equation? Well, we know that f of x is equal to ax squared plus bx plus c. All we have to do is find out the coefficients for a, b, c. This is what we're trying to find. Okay, a, b, and c. Just like the first three letters of the alphabet. Not saying much. Okay, so let's get started on this problem. Let's say to give you a point, f of, let's say when we put -1, we end up with -2. So a function of -1 is -2. They also give you function of 1 is going to be equal to 6. And we also know that they give you f of 0. When you input 0 for your x, your y value, which is your output, is going to be also 0. So that's your input, that's your output, right? What does this mean? F of -1 equals -2. When you plug in -1 in for your x, you end up with f of x, right? Which happens to be -2. This is called uh, mapping process, right? And so you start off with the input of -1, you end up with -2. In coordinate form, this means when x equals -1, my y value is -2. Or, rewriting this, I get -1, -2 in condensed form. Did you get that point? That was a pun, by the way. Okay, so let's go on. F of -1 equals -2 means it's going to be -1 comma -2. F of 1 equals 6 is going to be 1 comma 6. And f of 0 equals 0. 0 for your x, 0 for your y. This is your 3 points that you're given. With these 3 points, you will have a perfect equation for a parabola. Every time you have more than 3, you're going to have a regressed equation or best fit quadratic equation. But if you have 3 points, you're going to have what's called a regression of a perfect fit for any parabolic equation. So what we're going to do is we're going to plug in this guy in first, okay? Let's see what happens. F of 0 is equal to a times 0 squared plus b times 0 plus c. And that has to equal 0 as well. Which 0 am I talking about? I'm talking about this 0 being this 0. Let's redefine it a little bit further. I'm going to use blue. I'm going to use red. No. I'm going to use blue. This 0 is going to be this 0 right there. Right? So that's your x value. That's going to be your y value. When you plug it in, let's evaluate a little bit. 0 squared is 0 times a is 0 plus b times 0 is 0 plus c is equal to 0. That means c equals 0. We got one of them. Okay? Okay, so let's do another one. I'm going to use a different page to get to the second equation and the third equation. So we also have f of -1 is equal to -2. We start out with f of x is equal to ax squared plus bx plus c. But we know our c value is 0 right there. So what do? We know that f of -1 is equal to, we plug in a times -1 squared plus b times -1 for your x has to equal -2, right? That's your y value. -1 squared is 1 times a is a minus b. B times -1 is minus b equals -2. This is equation A. Let's do the third one. It says that f of 1 is equal to 6. Let's plug it in. F of x is equal to ax squared plus bx. We noted that the c value was 0 previously right over here. So what we do is we plug in f of 1 for your x value. Okay? A times 1 squared plus b times 1. That has to equal 6. That's your y value. 1 squared is 1 times a is a plus b has to equal 6. You have two equations with two unknowns. Well, what are we going to do? We're going to probably use linear combination, or another word for linear combination is elimination. We're just going to put this on top of this. A minus b is equal to -2. That's equation A again. We're just going to add. We get a plus a is 2a. B plus -b, that cancels out. 6 plus -2 is 4. So a equals 2, dividing by 2 to both sides. Okay. Since we found out what a was, you could plug it into equation A or B. It does not matter. Let's plug into A here in equation B. Since A equals 2, comma, B must equal 4 plus 2, because 2 plus 4 is 6, right? We have everything that we need. So the function looks something like this. F of x is equal to 2x squared plus 4x plus c, which is our 0 value. So the function is f of x is 2x squared plus 4x. Let's look at example number 2. Okay. How do we find the graph of this? I'm sorry, given 3 points, 0, 0, 1, 6, and -1, 2 using calculator. Okay. Show you how to use the calculator on this to try to figure out the quadratic equation. First thing I want to do is turn it on first. There it is right there. And then I'm going to make a list. So I go to stat right here. I'm going to create and edit this stats. And I'll go to, that's L1. So list 1 is your x value. L2 is going to be your y value. So list 1 is 0, 1, -1, 0, 6, -2. Okay. Let's see if that works or not. List 1 is 0, enter, 1, enter, -1, enter. Use the right arrow key to get to list 2 column. 0, enter, 6, enter, -2, enter. Okay. So I made list 2, 2 lists. I quit. I go into stats again. I go into calculate. I go into quadratic regression right over here. It's number 5. And it says X is your list 1, the column that we just made. I noticed that that's not the case. It's not list 4. It should be list 2. So I have to clear that. And then how do I find list 2? I go into second list, and I go into list 2 right there. You see that? So I went into second and then list. So because I was on the wrong list. I did that on purpose, by the way, just to let you know. And I calculate that, and I found that my A value, A equals 2, B equals 4, and C equals 0. What is that? R squared, the residual is 1. That means it's a perfect fit, guys. Got it? So review this if you want to figure out how to do this on your calculator. Okay, so remember it's y is equal to ax squared plus bx plus c. The function looks like this. A was 2x squared plus b was 4x plus 0. We don't need that. And let's look at that. Wow, deja vu. Hope you enjoyed this video, and hopefully this will help you in some of your homework. Good luck.